laying conflict amid the desert and grassland of Southern California. The western diamondback ratter is the one of the most patient predators in the world. Hi, my name is Hami Ainaa, and yes, western diamondback rattlesnake is our topic for today. Snakes, we know, have more than 3,000 species, each with its own venoms, potions, tactics, and speciality. However, these snakes live largely solitary life, hiding away, waiting to ambush their next meal. It can be a long wait. If necessary, they can go for 2 years without feeding. But when change arises, they are among the deadliest and most efficient carnivores on the planet. Like all snakes, their first weapon is not size or strength, but speed. But none of the above will work without speed. Common superpowers of snakes in the world are speed, but speed alone. What and why is this animal is so special? They can kill human and really dangerous predator in the world. Yes, that is right. According to research published in March 2016, an average snake strike lasts somewhere between 44 and 70 milliseconds. To put that in perspective, it takes humans around 2,000 milliseconds to blink an eye. In the same time, the most ruthless snakes could theoretically have carried out 4 strikes. This is title of news that I can show to you how fast these predators doing their job. It is almost inconceivably fast, and it means that snakes are far better at striking their prey than we are moving any parts of our body. In fact, if we were to move at the short accelerations that snakes do, we would black out. Essentially, the prey doesn't stand a chance in most encounters, says David Penny of the University of Louisiana at Lafayette, as well as a variety of venomous and harmless snakes using high-speed camera. We were talking about animals that can strike out and reach their target before the prey is even perceptually aware that it's under attack. It is not just redless snakes that can move this fast. Out of the estimate 3,500 snake species on the planet, from the tiny vipers to biggest pythons, very few have been studied. But those of investigated to date, many of capable of generation these mind-boggling accelerations. This is down to snakes' unique psychology, which has been finally honored over millions of years. Next, for one thing, they have a lot of muscle. The human body contains somewhere between 700 and 800 muscle. Snakes, even though so small they can sit on a coin, have between 10,000 and 15,000 muscle. We do not yet know how snakes exploit this muscle to move quiet and explosively. Some believe that they all connect together, building up energy for the strike before springing in the one elastic movement like a rubber band. But one particular aspect of snakes' attacks are even more baffling because they attack such a short space of time. Snakes have to withstand extraordinary force on their bodies, force that would completely incapacitate virtually any other animal. Penny found that snakes experience force of up to 30 g and 30 times the force of gravity when accelerating towards their prey. In contrast, even the most highly trained fighter pilots lose control of their limbs at 8 g when performing extreme maneuvers of short period time, any more than 10 g, and they quickly lose consciousness. We know that chameleons and salamanders shoot their tongues toward their prey when attacking, and they can hit accelerations which are many times greater than snake strikes, said Penny. But the key difference is that the tongue is not traveling, but is traveling, not brain. The tongue is traveling, not brain. The brain declares organ that's super sensitive to accelerations and impact, says Penny. That's why American footballers have helmet and concussions are such a serious thing. When a fighter pilot experiences strong accelerations, blood is pushed toward their feet, depriving their brains of vital oxygen. If this is happened too rapidly, the blood cannot return to their brain quickly enough, and they lose consciousness. But snakes manage to circumvent this and remain fully in control, while moving at far greater accelerations and striking their prey with venomous force. Part of the explanations may lie in the structure of their skull. So, as you can see, the structure of their skull. Ridiculous, right? So ridiculous. This skull of a snake is incredibly kinetic and mobile, said Penny again. There are so many different joints which allow stretching and mobility. It could be that if one of part land first, it can observe a little bit of shocks before that transfer to another part. So, the snakes can observe the impact of the strike far easier, and it doesn't concern them. Penny trying to compare it to the punching bag rather than brick wall. As he put it, the wall isn't moving that much to observe the impact, while the punching bag moved to displace some of that feeling. Scientists are now trying to understand how the snake's skeletal and nervous system behave under the extreme condition. The goal is to use that knowledge to move ourselves safer in scenarios where our own body might be exposed to large force. And quick review. Venom. Diamondback venom is a potent hemotoxin that kills red blood cells and causes tissue damage. Bites are extremely painful and can be fatal to humans. However, antivenom is widely available throughout the snake strains, and bites rarely result in death. This stiff rater, when concerned raiders reversely shakes their iconic tail as a last warning to back off. Redlegs are made of loosely attached hard, hollow segments. Snakes add a new radial segment each time they shed. However, raiders break off their frequently, and snakes may shed their skin several times a year, so it is not possible to determine a snake's age by its radial size. Threat to survival. This eastern diamond is not endangered, but because of the indiscriminately killing, the widespread loss of habit, and hunting its number and decreasing tongue its range. So the conclusion is Western diamond raider is the common superpower of snakes in the world are speed, not size, not weight, but speed alone. So that's all from me. Hope to see you next time. Thank you so much. Bye.